my name is Ethan Page, and I'm here to show off a game I built in about 24 hours over the past 3 days. 2.5 days. Regardless, it's called Space Plow. The idea behind it being, think like a snowplow, but in space, clearing asteroids. It'll make sense soon enough. Now, if you've seen the past 4 videos I've made, you will notice that those are tutorials in Unity meant to show off some, let's say, more advanced topics, coding practices, techniques, things of that nature. This sort of game here is basically a final project, a culmination of each and every one of these things. And as such, I will have utilized quite a few of these topics from those past 4 videos in this project. So, just to give it a quick play, eventually. You'll notice there is some audio. I'll turn that down for now. We have the various buttons, different all work. This is the general backstory. You are just a humble space plower. It's your job to keep the interstellar highways free of asteroids to prevent deep space crashes. It's not a glamorous job, but someone has to do it. You just try to see it as a game to keep yourself entertained. Also explains, you use WASD to move, and you press the spacebar to shoot. And you'll notice that little lightning bolt there. That is a power-up. Otherwise, you move around and you shoot the asteroids. After all, it's keep everything clear. Now, that power up I just grabbed slowed time down. It kept me around the same speed. I'm also able to hold the spacebar down and just fine. Well, I prefer to win my shots. Now eventually, if I were to, let's say, crash, it displays my final score. If I had beat the original high score, it would also tell me that as well. And from here I can either restart. I also have a pause menu, which, as you can see here, does pause things. I can also then access the options to turn off or down the music or the sound effects. And I can return to the main menu. And then this would run application.quit, but I am the editor still, so it won't show that. So that is just the gameplay of the game. It's short, sweet, and simple, but it does what it's meant to, and that is display these coding practices. Now, the practices in question, there are a few things, so I will show them off as I get to them. To begin with, we have namespaces. This is really the only one I use, just, again, to get it in there to show that it can be used and what it's used for. I have my namespace of save data. There could be more in here in future iterations, but just to prove a point. This will hold scores, specifically the high score. Now I do have play data elsewhere, in fact in player data. But for now, we'll just worry about this. In my game manager, we have the high score strings, all this relating to high score, even so much so that, well, what this chunk of code does is it takes this namespace, this class, the score data, it creates it, and then, or it iterated it out and saved it to an output JSON file. From there, it will then, in the update, will check for whether or not the local score variable, the score that I got in there of 12, is greater than or equal to the local data score, which is the namespace score, the high score. If it is larger, then it pings up high score, which shows that message at the end, and then goes about updating the high score. It once again loads the file as per resource loading, which you can see in that line specifically there. Pulls the data from the file, saves it as a text asset, converts it to string, and then changes the value, or rather makes it a new object of the play data type, updates the data, saves it as a string, and then saves it back to the file, allowing for between game data saves. In this case, keeping track of the score. Utilizing StreamWriter to write to it, and JSON and resource loading to otherwise save and pull the data. Now, I also use scriptable objects, specifically for the asteroids, only 2 variables here, and for the player, which, as you can see, a few more variables here. You can also see these in the inspector. If I go to my resources, you have the player ship and the asteroid, as well as the high score record. Just to show off the high score, currently it is 22. I've done a little bit of testing. These scriptable objects allow, as I explained in the last video, allow for default values of things to be set and saved. I will always have this to return to for an object if need be, as well as having this as a basis so that all of the objects of the respective types will spawn beginning like this. Now, as well as that, we have getters and setters in here, commonly used with health stats. As such, I use them with health stats. If the health of the asteroid got to be below 0, then it triggered the die command, which sets it inactive and plays a sound. Otherwise, it also implements the iDamageable interface. As you can see, the play data does the same, and also has the getters and setters. Now, the interfaces, I have iDamageable and iDamager. Slight break from the naming convention, but I feel like it fits. After all, it is something that it does, and that is simply it deals damage. This I made a static so that it could be implemented from anywhere if need be, which in some cases, as things like the bullets were damaging things and made it difficult to implement these properly without having to do too many get components, which, as you may know, leads to some slower programs. I wanted to avoid that. Now, as far as the main requirements for this project to show off these codes, that was the namespaces, interfaces, getters and setters, and scriptable objects were all shown off. I also had to do coroutines, which I have in one of these. I need only find them. I did use coroutines a decent amount in all of these. They are scattered throughout the program, I will admit. Ah, yes, there it is. Start coroutine, get data. There are a few more files. This is not all of my files. These are just the select few ones I kept open to show off the coding practices I used. This chunk of code here also acts as resource loading from the web, as you may be able to guess from the URL here. This allows for the star, space and stars background image that loaded up when I clicked play. If it looks like there was a bit of delay in that loading, it's because it was pulling it from the web as opposed to just because of a slow program. But it was in the beginning, which makes it appear as it's just though the game is loading. Nice little, for want of a better term, excuse. So this took care of a coroutine. Again, there are more, but also pulled from the web, which was one of the bonus requirements, just to see how many of these other things I could fit in. Now, as well as this, I also used, in the player controller, a delegate. Right there, specifically. This was just so that the player can move. After all, I only really needed the one delegate to be able to store all of the movement functions. If I hit, you know, left and right, well, then they'd cancel each other out, because they were both being called and iterated at the same time. But I only need the one delegate to prove that, which ends up saving a bit of code, even if it ends up just compressing it into this one block here. These, of course, just specify that it is turning. The actual movement code is in the player mover script. On top of that, I did also have the shooter, which is in the player shooter script as well. So, excuse me. Onto there, the background screen again. This is where I loaded textures. I also did some custom editor scripting, just a really simple script, which was just to count how many objects there were on screen in edit mode, inactive or otherwise. As you may remember, if you've watched my other previous videos, I did have a script very much like this in one of those previous ones. I believe the 4th video. This one is a slight improvement to that, as one of the things I found that I mentioned in the video as well as a minor annoyance was that in the editor update, it will only ever update in the editor when you move or change something, which is fine. However, as soon as you play, it will update as a normal. I got rid of that with just a simple if condition. If it's in editor and it's not playing. If the application's playing, it stops. I don't get thousands of this program telling me there are 13 objects available, things like that. Finally, this is the object pool. The object pool, as again I covered in the previous video, allows for a slightly more streamlined and less data intensive setup for having masses of objects, such as, in this case, the asteroids. The asteroids are all put into a pool, instantiated right then and there, and set inactive, and only set active and teleported to where they need to be, when they need to be. I also made use of the Unity event system in my game event manager. It was a few things, such as game start, game pause, unpause, player death, just a few things. And when each one happened, not that one, I made a few things happen. Pause and unpause, as you may guess, are fairly simple. I set the time scale to 0, which paused all action and just brought up the menus. Unpause did the exact opposite, set timescale back to 1. Player death moves the screen to game over, as you saw then at the end as well. Give this one more quick play just to sort of point out when each of these things were used. I will not play it immediately, as I should probably unload the scene before I play it. Turn that down again. So, once again, I make use of the event system here as well. More the built-in version, after all it is through the UI, not quite my own custom one. That begins here. Just shooting, using the delegates, the object pool is already in motion, making sure all of these asteroids... There we go, I power up the effect. You'll notice that the asteroids are passing through each other. Only 7 that time. That is because to fix a few issues, I ended up putting the player object, the asteroids, and the asteroids on their own separate layers. I also created some invisible walls so that you couldn't just fly off the edge of the screen. and those were on its own layer as well. I made it so that the player will only interact with the invisible walls, and the asteroids will not. The asteroids will not interact with themselves, nor will anything on the player object, e.g. the bullets. But the player layer and the asteroid layer are more than willing to interact with each other. This video is a bit shorter than the others. It's more meant to be just a quick showcase, showing off a little bit of code, how I used it. If this is the first one you're watching, then it may be worth going and having a look at those other 4 as well, to see slightly more in-depth and slightly simpler examples of how each is to be implemented. Thank you very much. It's been good having you.